Welcome to the deep dive. Ever feel like data science is just full of jargon? Like you're trying to solve this massive puzzle and you don't even recognize the pieces.
Oh, absolutely. It can feel overwhelming at first, for sure. Like everyone else just gets it.
Totally. And you feel like you're the only one lost. So today we're going to try and demystify some of it. We're looking at a really clear explanation from someone named Rajiv.
Yeah, it's a great starting point. The idea is to cut through that noise and really get to the core concepts, make them click.
Exactly. So our mission today, explain these fundamental data science ideas simply, make them engaging.
Let's do it. Think of it as getting the basic building blocks in place.
Okay, so where do we start? Rajiv kicks off with something called regression. Now, forget the name for a sec.
Right. At its heart, it's just about finding patterns. Yeah. Spotting how things are connected, so maybe you can predict what happens next.
Like Rajiv's example, it's hot outside, the temperature's high.
And suddenly ice cream sales go way up. That's a pattern. Regression helps us quantify that, put numbers on it.
Okay, so how does that work? There's a formula, right? Y mx plus c. Sounds a bit mathy.
It does, but let's break it down. Y is what you're trying to predict the ice cream sales. X is the thing influencing it, the temperature.
Okay.
And that's the slope. It tells you how much sales tend to change for every degree the temperature goes up or down. And C
is the starting point. Like, even if it's freezing, you might still sell some ice cream.
Exactly. It's the baseline, the intercept. So YMX plus C just describes that straight line relationship.
Got it. One thing affects another. Simple enough. But real life's usually more complicated, isn't it? Selling ice cream. It can't just be the temperature.
You're right. Maybe it's a weekend, or like you said, a holiday, or maybe you advertise a new flavor. Lots of factors.
So what happens then when there are multiple things going on?
That's where multivariate analysis steps in. Multi meaning many, meaning variables or factors.
Ah, okay. Like Rajiv's example about house prices. That makes sense. It's not just how big the house is.
Precisely. The size matters, sure, that's one factor. But so does the number of bedrooms, maybe the age of the house, the location rating.
Right, location.
Definitely. So the formula just expands to include those extra factors. YM1X1 plus M2X2 plus M3X3 plus C.
Whoa, okay. Looks a bit more complex now.
It looks it, but the idea is the same. Y is still the house price we're predicting. X1 is size, X2 is bedrooms, X3 is location rating.
And each one gets its own its own level of importance.
Exactly. M1, M2, M3. They're the weights. They show how much each factor bumps the price up or down on average.
Okay, so that clears up the difference then. Simple regression. One predictor, like Rajiv said, maybe salary based on years of experience.
One X influencing one Y.
And multiple regression. Lots of predictors, like our house price example with size, location, all that stuff.
Correct. Multiple X's influencing the Y.
Makes sense. But are relationships always straight lines? Like, does adding one more year of experience always add the exact same amount to a salary? Or does growth sometimes curve?
Great question. No, things aren't always linear. Sometimes the pattern is definitely curved. That's nonlinear regression.
Okay, nonlinear. Like what?
Think about bacteria growing in a dish, Rajiv's example. It doesn't just increase steadily. It often starts slow, then suddenly, boom, it grows exponentially.
Ah, right. The J curve or whatever.
Yeah, or an S curve sometimes. So we use different mathematical models for those like exponential curves, logarithmic ones, polynomial ones, to capture those non-straight line patterns.
Interesting. So we can predict numbers, straight line or curvy. What about predicting, well, not a number, but more like a yes or no? Will someone click the ad? Will this student pass the exam?
Good one. That shifts us into logistic regression and classification. We're predicting probabilities now, the chance of something happening.
Okay, logistic regression, how does that work? Rajiv mentioned study hours and passing an exam.
Yeah. Instead of fitting a straight line, we use a special S-shaped curve. It's called the sigmoid function.
Sigmoid, okay.
It takes your input, like study hours, and squishes the output, so it's always between 0 and 1. Think of that as the probability, 0 meaning no chance, 1 meaning definitely happening. So maybe more study hours push the probability of passing closer to 1.
Gotcha. So it gives you the odds, basically. All right, we've covered predicting numbers, predicting probabilities. Now, Rajiv also quickly mentioned some more advanced techniques for really messy, complex data, multivariate analysis techniques. Sounds Heavy?
They can sound intimidating, yeah, but they're really tools for making sense of situations where you have tons of variables, lots of data points. It's about finding the underlying structure.
Okay, like what? He mentioned PCA.
Right, principal component analysis. PCA is super useful. Imagine you have data with like 50 different measurements. PCA helps you boil that down to maybe just a few key components that capture most of the important variation. It simplifies things.
So reducing the dimensions, kind of. Find the main ingredients.
Exactly. And then there's factor analysis, which is sort of similar, but it tries to find underlying hidden factors or traits that explain the patterns you see in the data.
Hidden patterns. Okay.
Oh.
And cluster analysis.
That one's about grouping. Finding natural clusters or segments in your data, like grouping customers with similar buying habits.
Makes sense. And the last one, discriminant analysis.
Discriminant analysis is more about classification. If you already know the groups, it helps you figure out the best way to distinguish between them based on the data. Like what characteristics best separate successful projects from unsuccessful ones.
Wow, okay. That was quite a tour. So if we zoom out, the big picture seems to be data science is this toolkit, right?
It really is. A toolkit with different methods, regression, classification, these multivariate techniques.
All designed to help us find patterns, make predictions, and just generally understand complex information better.
Couldn't have said it better myself. And it's not just theoretical stuff. As Rajeev pointed out, these techniques are used everywhere.
Yeah, you mentioned AI, finance.
Retail, healthcare. I mean, think about banks predicting loan defaults, stores figuring out inventory, doctors analyzing patient data. It's all built on these fundamentals.
So maybe a final thought for everyone listening. Think about your own world, your work, or even just daily life. Where could understanding patterns or predicting outcomes be, genuinely useful?
That's where the real power lies, seeing how these concepts apply.
Absolutely. And look, this was just scratching the surface of First Dive. There's obviously way more to explore with each of these ideas.
Definitely. Keep exploring, keep asking questions. It's a fascinating field.
For sure. Thanks for joining us on The Deep Dive.